Good afternoon. The next section of the 2014 product brochure for dynamic engineers I want to discuss involves a niche category of TCXOs. It can really apply to OCXOs, any kind of oscillator, and that is the integrated module in a larger package. When I say larger package, I usually mean old package, or politically correct way of saying it is legacy package. We do a lot of projects with customers all over the world on supplying older TCXO technology packaging using new technology inside. What I mean by that is a customer might need a motherboard, a 25 by 15 millimeter circuit board as a TCXO with a certain kind of functionality such as 50 ohm sine wave or a mechanical frequency adjust, or they're driving it with a 12 volt supply instead of a standard TCXO supply of 3.3 volts or 5 volts. We will do the design work, the value-added design work, place a small technology module on the motherboard along with the support circuits to generate the custom TCXO that the customer is looking for. And again, all of this work is done in-house, whether it's in our Houston operation or China operation or European operations. We all do this in-house to participate as much as we can in the integrated module market. The examples in the brochure, here's one 9.6 megahertz, 5 volt TCXO, but look at the dBm. It's a 10 dBm typical output. That's very high power for a TCXO, where customers typically use clip sine or HCMOS. So a 10 dBm, 50 ohm load TCXO, in addition 250 parts per billion stability, or 0.25 ppm, very low stability, minus 40 to 70, on a motherboard that's 25 by 15 millimeter. All of this work took the cooperation of numerous engineers and a couple different factories to help us put the design together. Another couple examples in the product brochure, the T79 series, 20 and 50 megahertz, 3.3 volt CMOS. These dip package, 20 by 15 by 10 millimeter packages, inside on the motherboard are smaller 5 by 7 modules obtained from the big volume factories, and again support circuits around them to generate the requisite performance. Now here you notice minus 45 to 85. In integrated module approaches, we will entertain from the customer temperature ranges that are outside the industrial temp range, minus 40 to 85. You might get customers minus 45 to 90, minus 50 to 100. We love those kind of customers. They're not easy requirements to satisfy. But again, we will work with a factory to get an extended temperature module that we can put inside the larger package. Now, one of the complexities when you get outside the minus 40 to 85, what we need to do with that customer is have what I call a graduated stability requirement. For the narrower temp range, minus 40 to 85, we might specify half a ppm. From minus 55 to minus 40, we might ask the customer to accept plus or minus 2 ppm. From 85 to 100, we might request plus or minus 2 ppm. In other words, the stability levels on the exterior, right on the extreme limits of the temperature range, we're going to need wider ppm. Why is that required? In crystal physics and crystal science, the crystal angles, the angle that the crystal is cut at, for the very cold temperatures and the very hot temperatures, the slope of the crystal curve is at its maximum. Maximum negative or maximum positive. Because the slope of the crystal is very steep, the compensation circuits used to bring a 20 ppm crystal down to less than half a ppm, the compensation circuits have a very difficult time compensating the crystal at the temperature extremes. So there will be times when we have an integrated module opportunity as a TCXO, and the first thing I'm going to ask for with you and your customer is to consider multiple stability requirements Wider stability requirements at the extremes, a better stability requirement in the middle. But integrated modules, again, is a very profitable niche opportunity for both of us because it's non-standard and the general factories generally want nothing to do with those kind of opportunities. They're not big enough, in other words, for the big factories. Thank you very much.